Okay, so problem number 4. Problem number 4 is quite similar to problem number 3, but in this case you need to use p-value method. You need to do the hypothesis testing, but instead of critical value method, you must use p-value method here. Okay, let's see. A lawyer claims that more than 25% of all lawyers advertised. A sample of 200 lawyers in a certain city showed that 63 had used some form of advertising at alpha equal to 0.05. Is there enough evidence to support the lawyer's claim? Okay, so let's introduce again our H0 and our 0. It's P equals to 0.25 and H1 more than P is greater than 0.25. Be careful with the notations. Notate proportion as P, and we are annotating mean as mu. So those are standard notations, and if you mix them and notate, let's say, mean as P, so then I kind of start like to doubt like if you understand what's going on. So don't do it. Use those standard notations. Okay, this is our claim. Yeah, this is our claim, and this is the right tail. Okay. Absolutely same first step. Then we introduce our alpha. Our alpha in this case is equal to 0.05. This is our significance. And here we are not calculating the critical value. We calculate test statistic next. And based on test statistic, we are going to calculate p-value. Okay. Okay, let's see. Test statistic, here's the formula in this case. P with the roof, so that's a sample proportion. And sample proportion, we have 200 lawyers and 63 they advertise. So let's maybe put our parameters. P in our case is 0.25. Q, so that's 0.75, and P roof, yeah, let's call it. It is equal to 63 divided by 200. Okay, so this is for the sample. Yeah, so this is for the sample. N is the sample size, and N is equal to 200. Okay. Okay, let's calculate test statistic. Test statistic. And test statistic in this case is equal to P roof minus P, okay, divided by square root, and here we have P multiplied by Q, so which is 1 minus P, and divided by N. There. Okay, that's it. Yeah, so that's it. So that's what we have, and this is our test statistic. Our test statistic is 2.12. Okay, and this is our right tail. We will calculate p-value. P-value when we are running the test for proportion, if we are calculating the confidence interval for the proportion or the sample size, we always use normal distribution. Okay, so let's see normal distribution, and this is the right tail. So we need like to see that area to the right normal standard. Yeah, that's normal standard distribution to the right from this value. Yeah, because if you take it like that, it's going to be to the left. Yeah, and we need area to the right. That means we need to subtract it from 1. Okay. Okay, so this is our p-value. This is our p-value, normal standard distribution, or cumulative. Yeah, so this is cumulative. Okay, it is equal to 0.0168, and this is less. Yeah, this is less. This is less than 0.05. Our p-value, it is less than 0.05. Okay, so that means that we are rejecting H0. Yeah, so we are rejecting H0. Reject H0. We reject H0, and our final conclusion, we have enough evidence to support the claim that more than 25% of all lawyers advertise. Okay, that's it. Yeah, so that's it. So that's how we do it using the p-value method. So steps are the same. Yeah, so steps are the same, but instead of taking alpha and calculating the z-scores which cast at alpha, we take test statistics and calculate the area which is being cut by this test statistic. Okay, so let's see the problem from quiz number 2. Let's calculate the p-value. A researcher claims that the average yearly consumption of bottled water in Canada is equal to 27 liters per capita. In a sample of 50 randomly selected Canadians, the mean yearly consumption of bottled water was 29.3 liters. The standard deviation of the sample was 1.8 liters. Find p-value for the test on the basis of the p-value if the researcher's claim valid. Is equal to, so it's equal to or not equal to. In this case, this is two-tailed test. Yeah, let's maybe set the H0 so we can see everything. And this is the mean. Yeah, so this is the mean. And in this case, it is mean. Oh my god. Let's just put it mu. Mu, in this case, mu is equal to 27 liters, and H1 mu is not equal to. Okay, let's see if it's going to work. Okay, not equal to. Let's see, maybe that symbol is going to work. Yeah, so we have two of those. No, for some reason, I don't know, like it does this strange stuff. So let's maybe try this one. Okay, so this one works. Okay. So again, guys, if it doesn't work, does something like this, so you can find it in the list. In the list, you can just use mu if you want to. So that's totally fine. Oh my god, why does I'm not sure like why it does it. So this one, okay. Come on. Okay, so that's what we have, and this is our claim in this case. This is our claim in this case. And our test statistic, let's calculate test statistic, test statistic in this case. It is equal to the mean yearly consumption of bottled water was 29.3. So this is 29.3 minus the population 27 divided by standard deviation of the sample. We are going to use t-distribution here. It's 1.8 and divided by squared root of 50. So that's our sample size. Okay, so this is our test statistic. Yeah, as you can see, in this case, our p-value is going to be extremely small, because we are far away. Okay, so p-value is equal to, so we have t-distribution, and we will take two-tail. Yeah, so we will take a two-tail, so it's going to right away like double it, because we need to double, so double like the tail in case of the two-tail test. But that's what this function does, and it's this, and degrees of freedom 49. Okay, yeah, so it's this, this value right there. So this is extremely small value, you see here, like if it's less than significance level, so we reject H0. Yeah. So what are like significance levels we are usually taking? So that's 0.1, 0.01, 0.05, and so on and so forth. Yeah. So here our p-value is zero. It's zero. So that is why we are going to reject H0 at any reasonable significance level. Yeah. So we reject H0, and we do not support researchers claim that the average yearly consumption of bottled water in Canada is equal to 27 liters per capita. Okay, that's it. So that's what you will need to do in problem number 4. So let's move to problem number 5.